Endothermic versus exothermic chemical reactions. Let's focus on what is the difference between endothermic and exothermic. Endothermic means a chemical reaction that absorbs energy from its surrounding. Exothermic reaction is energy released to the surrounding. In endothermic reactions require an input of energy because energy absorbed reaction we called endothermic. The surrounding is usually gets cooled after the endothermic reaction. Let's see what is the energy diagram, how we can draw the energy diagram for endothermic reactions. First we need to draw the axis. The y-axis energy and the x-axis is reaction coordinate, or we call reaction progress. Then we need to mark reactants and products. In endothermic energy diagram, reactants at lower energy, products are at higher energy level. You can see the dashed lines marked reactant energy level and the product energy level. This is products, this is you need to place the reactants, but this dashed line indicates the energy level for reactants, energy level of the products. Transition state is the top of this curve. And then activation energy barrier. Activation energy barrier is the energy difference between reactant energy level to the transition state. That is energy required for reactant molecules to give the products. Next, delta H. Delta H we call heat of reaction, or another name is enthalpy change. This is the energy difference between product's energy level to the reactant energy level. Delta H is equal product energy minus reactant energy. In this endothermic reaction, you can see the product energy level is high, reactant energy level is low. The product energy minus reactant energy is a positive value for delta H. Enthalpy change is plus value or the positive value for endothermic reactions. Let's see some examples. Photosynthesis. In the presence of sunlight and chlorophyll, this carbon dioxide and water used to produce glucose and byproduct is oxygen. This photosynthesis reaction is endothermic reaction, energy absorbed. Second example, dissolving ammonium nitrate in water. When it dissolves in water, it dissociates into ammonium plus cation and nitrate anion. Again, this reaction is endothermic. Exothermic reactions release energy to the surrounding, most commonly as heat. And the surrounding usually gets warmer after exothermic chemical reactions. Exothermic reaction energy diagram. The same way the x and y axis label and reactants and the products. You can see here reactant energy is higher in energy, product at lower in energy. Exothermic means reactants release energy to give the products. Transition state, again the top of the peak we call transition state, and activation energy is the same definition, the energy difference between transition state and the reactant energy level. Delta H is again the same definition, the energy difference between reactant energy level to the product energy level. The way we calculate delta H is, however, product energy minus reactant energy. Here, the product is at lower energy, reactant at high energy. Therefore, delta H value for exothermic reaction is negative value. Examples. Combustion reactions are exothermic reactions, heat released. For example, methane combustion is given here. Next, respiration reaction. Cells release energy from glucose to produce carbon dioxide and water plus energy as ATP. So this is another example for exothermic reaction, energy released to the surrounding. So as a summary, endothermic reactions, energy absorbed, exothermic, energy released to the surrounding. Endothermic delta H is positive value, exothermic delta H negative value. Endothermic reactions cold to touch, exothermic reaction warmer to touch. And endothermic reactions energy diagram. Reactants lower energy, products high energy. But exothermic reactions energy diagram. Reactants are at higher energy level, products are at lower energy level.